or not. And in this case, we are interested in whether their variances are equal to each other or not. Okay, so in this case, the null hypothesis is sigma 1 square is equal to sigma 2 square. And the alternative hypothesis is that these two are not equal to each other. So basically, we need to use the sample variance S1 square and the S2 square, use them as a statistic, okay, to first as an estimator for sigma 1 square, sigma 2 square, etc. And then we need to find out what kind of distribution to use in this kind of hypothesis test. Of course, we know it uses variance, right? And there is something related to variance, that is chi-square distribution. Okay, for chi-square distribution, this is, okay, what is the general form? The general form for chi-square distribution is this. We know n minus 1 times sx squared divided by sigma x squared. We know this is chi-square distribution with degrees of freedom n minus 1. Okay? So basically we know this. But somehow we have to test two variances. Okay? So another distribution that is related to two variances is this. F distribution, right? F nx minus 1, ny minus 1. We know F distribution is this, right? So we know basically it is like this, okay? And of course we know if it is chi-square distribution with degrees of freedom n minus 1, we know the form is like this, okay? So basically we just follow what's going on here and to simplify it further to see what we can get, okay? So then this one corresponds to this form, right? So sigma x squared and nx minus 1 sx squared divided by nx minus 1, right? Any questions? And then from here we know the denominator, that is ny minus 1 sy squared divided by sigma y squared and divided by ny minus 1. Any questions so far? So we know there is nx1 here and nx minus 1 here and nx minus 1 here, so it can be cancelled out, right? The same thing, there is ny minus 1 here and ny minus 1 here, so it can be cancelled out. Okay? So basically what do we get? We get sx squared divided by sigma x squared and sy squared divided by sigma y squared. Any questions? Okay. And then we want to simplify further. We put sx squared and xy squared together and sigma x squared and sigma y squared together. So how do we get it? So it can be written as the following. So sx squared and then sy squared times sigma x squared and sigma y squared. So basically, if you know F distribution with degrees of freedom nx minus 1 and ny minus 1, it can be simplified to this form, okay? So if you know F distribution, degrees of freedom nx minus 1 and ny minus 1, this is what you get, okay? This is what you get for the F distribution. Any questions so far? Okay, but what we want to solve? We want to solve this because for this question, we want to test, okay, whether sigma x squared is equal to sigma 2 squared. This is what we want to know. Because of this, we know we have to use a different kind of distribution, and it is F distribution. Okay, so this is F distribution, nx minus 1, ny minus 1. Because this is the only distribution that you have two variances here, okay? Sigma x squared and sigma y squared. Okay, so basically, if you want to test variance, okay, then you have to use F distribution. Now the question is how to apply this, okay? So we know F distribution is equal to this, right? And we want to test this. So the same thing, when you do hypothesis test, first you have to put down the null hypothesis and alternative hypothesis, right? This is the first step. And then the second step, you have to determine significant level, right? According to the book, according to the question, the significant level is 0.10. So that is 10%, right? So this is a 10% significance level, right? And then the second part, okay, after you determine the significant level, and also we already found out we should use F distribution, right? And the statistics for that is S1 squared and S2 squared. Then you have to calculate the observation value, right? So what is S1 squared? According to the questions, it is page 416, is that right? So according to the questions, what do we have? The question tells you a lot of numbers, right? So from those numbers, you should be able to calculate the, so let's get to the number here. So you have root 25 and interstate 75, okay? And this is what you have. Okay? And then you have 59, 60, 61, 51, 56, 63, 57, and 65. So from the numbers here, you can get x bar 1, right, and s1 squared. And then here, x bar 2, s2 squared, right? Okay, so let us check the book. What's the number we have? So from the question, we know x bar 1, okay? X bar 1 is equal to 58.29. X bar 2 is equal to 59, okay? And S1 is equal to 8.9947. And S2 is equal to 4.3753, right? So this is what we have. Okay. Then it should be easy to get S1 squared and S2 squared, right? So how much is S1 squared? Can anyone help me with that? What's S1 squared? Anyone got a calculator? Remember to bring a calculator in final. If you don't have calculator, you get into trouble. Anyone got a calculator? Have you? None of you got a calculator? None. I cannot find a number here, so no one got a calculator, is that right? What's the number here? 80.90. What about this one? 19.14. Okay, so now For this case, right, we have to use F distribution, and we know the form, the general form for F distribution is like this. Remember, we are testing whether sigma 1 square is equal to sigma 2 square or not. And from this way, okay, we are basically assume this is true, right? Okay, we assume this is true, and we gonna test whether this is true or not. So then, if that means sigma 1 square is equal to sigma 2 square under null hypothesis, right? Under H naught, then this one basically is equal to 1 if H naught is true, right? If H naught is true, then this one is equal to 1. So the only thing that we need to plug in is here, okay? So then we have 80.90 divided by 19.14, okay? So give me the number here. How much is this? I think it's close to 4, right? 4.22. Okay, so this is our observation value. This is what we observe, okay? This is what we observe. And then we have to test it, okay? Compare this with the F star. This is the critical value, right? So we say if F naught is greater than F star, what would you do? If F naught, so this is observation value, right? If this observation value is larger than the critical value, then what would you say? You say reject H naught. So that means these two are not equal to each other, right? If this one is less than the critical value, then what would you do? You're going to accept H naught. Okay? Any questions so far? Okay, so how to figure out this value, right? Because in this case, we are testing whether they are equal to each other or not. So that is a two-tail test. Okay, this is a two-tail test. So when you have a two-tail test and the significant level is 10%, right? So actually, the critical value you are looking for, okay, so first we have to get the degrees of freedom, right? 1, 2, 3, 4, 5, 6, 7. So the degrees of freedom should be 6, right? And this one, 1, 2, 3, 4, 5, 6, 7, 8. So that degrees of freedom should be 7. So if you look at page 417, right? So you have a table there. It checks the significant level alpha is equal to 0.05, right? In this case, the significant level is actually 10%, right? It's actually 10%, but because this is a two-tail test, right? This is a two-tail test, so you have to divide this by 2, okay? So it is, you have to check 0.05. And you found out the value is 3.87, right? This value is 3.87, and the observation value, what you observe, the value you observe is 4.22. So what would you say? Which one you're gonna do? This one or this one? The top one or the bottom one? It should be the top one, right? Because this value, 4.22, is greater than 3.87. So you have to reject null hypothesis. So in this case, the first variance and the second variance, they are not equal to each other. Okay? Any questions so far? Any questions? So as I said before, if I'm going to make the final a little bit more difficult, right? I would ask you to test whether the variance are equal to each other or not first, right? And then if they are equal to each other, then you can use ANOVA. If they are not equal to each other, what are you going to do? You have to use the traditional hypothesis test. Okay? Any questions? Okay, let us get a brief review on the ANOVA. Any questions? Okay, we will do some more examples. So, okay, so what is the ANOVA table? So this is the sources of deviation, right? The sources of deviation, the first one is factor, right? The second one is error. So this one is we're looking at across the machines, okay? This one we look at across machines. This one is the sources of deviation due to error, okay? So it is coming from the same machine. We are looking within the machines. And this, of course, is the total, right? And then the second part is the sum of square, okay? Sum of square, for this one is sum of square due to factors, okay? Sum of square of the deviation due to factors. And this one is sum of square of deviation due to error. And this is sum of square of deviation total, okay? And then the second part is degrees of freedom, right? Degrees of freedom, usually we say we have R machines, right? And so the degrees of freedom for the factor is R minus 1, right? And here we are looking at within the machines, but we have R machines, right? So actually we are looking all of the samples, but with respect to R machines. So the degrees of freedom is summation Ni minus R, okay? And then for this one is summation Ni minus 1, okay? And then you get to MS part. So how are you going to get MSF? MSF is equal to SSF divided by R minus 1. And then MSE is equal to SSE divided by summation Ni minus 1. So basically, this is the table you have to remember, okay? You need to memorize all this, but it's not that difficult. If you can tell, okay, this is the factor, right? If it is factors, you are looking at the difference between machines. If you are looking at the error, right, you are looking at the differences within each machine, okay? So basically, you have to transform, okay, from those definitions into formula, okay? In this case, because you are looking at the differences among those machines. So what is that? You are looking at the first machine, the difference between the first machine and the population, the second machine and the population. So X bar I, okay, so that represents a different machine, I from 1 to R, okay? And with what's going on, of course, in terms of the whole sample, so that's X bar G. And remember, all these things has to be square, right? And for this part, okay, for this part, you are looking within the machines, okay, within the machines, and the differences of all the individual items within the machines. So that is summation Xij minus X bar I squared, okay? So basically, you need to memorize all this. But as I say, you just remind yourself what's going on in terms of the factor, right? You are looking across machines. So I machine, the first one, second one, and R1, and their difference between the whole sample, right? And this one, SSE, you are looking within the machines. You are looking at each individual items, right? Xij, that's each individual item. But you are looking at them within this machine, within I. Okay? Any questions? Now we want to get another example on this. So let us try this example and see what's going on. So we are looking at 4 typing methods, okay? We are looking at 4 typing methods. It's like we are looking at 4 different machines, okay? And this is what we have. We have deviation, right? Okay, so for this one, let us look at this one first. This one is 43, and this one is 1908, and this one is 104. Okay, so this is the table we have. So there are a lot of information missing here, right? There are a lot of information missing here, and you are required to fill in the numbers. Okay, so let us try. So because we know we are testing 2 different kinds of typing method, okay, we are trying to input something, right? And there are 4 different types of typing method. And from here we know the degrees of freedom, okay, for the total is 43, okay? Then you have to fill in these 2. So that's R minus 1, right? And summation Ni minus R, okay? And also, there's something missing here. SSF, SSE is not there, okay? And then you have MSF. You don't have MSE, okay? So in this case, can anyone tell me how much should be here? What is the degrees of freedom for the factors? It should be, how much should it be? How much should that be? What should be the number here? Degrees of freedom. The table is there, right? The formula is there. It should be 3, right? Because there are 4 machines, okay? 4 different types, okay? So then it should be R minus 1, right? Okay? Then what should be this number here? What should be the number here? How much is it? It should be 40, exactly, right? Because this one, 3 is equal to R minus 1, right? So that means R is equal to 4, right? And summation Ni minus 1 is equal to 43, right? So that means the summation Ni is equal to 44. And what about this number? This number should be summation Ni minus 4, right? So it should be 40. Any questions so far? You have to be able, definitely some kind of question like this will be in the final, okay? It may not be this easy, okay? But anyway, this is your reference, okay? This is your reference. This is what you need to know, okay? And from there, you can fill in all the missing information. Any questions? If you have questions here, okay, raise your hand. Make sure you understand all these, okay? You will be in the final. Then what about this? We know MS is equal to 104, right? Then what should be here? Because you know how to get MSF. It is SSF divided by R minus 1. So that means this is R minus 1. And times this one, then you get this one, right? So this one is 3, 1, 2, right? And so SSF is equal to 3 times 104. So that's 3, 1, 2. Questions? Any questions? Okay, then what about this one? Because we know SST is equal to SSE plus SSF, right? So basically this one should be easy. So SSE is equal to 1908 minus 312. So that is 1596, okay, 96, okay. 1596, okay, 1596. So what about here? Can anyone tell me what should be this number here? So this number is MSE. That is equal to 1596 divided by 40, right? So how much should that be? Excuse me? 0.9. Okay, 39.9. Of course, in this case, we are trying to test whether, okay, mu1, so there are 4 different types of, so the null hypothesis is mu1 is equal to mu2 equals to mu3 equals mu4, and the alternative hypothesis is that H0 is not true, right? So this is our observation value, okay? We observe that the value should be 39.9, right? Then we have to compare this one, okay, with the critical value, okay? So let us look at the question, see what's the critical value and all that stuff. Okay, where is... So the significant level, okay, the significant level we choose is 5%, okay? And you have to remember, ANOVA is a right tail test, okay? ANOVA is a right tail test. So you have to check which one should be the critical value. Of course, it is related to the degrees of freedom, right? So this is F R minus 1 and summation Ni minus R, right? And alpha. So this one is F star, the critical value, degrees of freedom 3, and then degrees of freedom 40, and then 0.05. Okay? So now, please check your book and tell me what is the critical value here. Check the table. Okay? If you have the book, check the table. Can anyone tell me what is the critical value? You don't have the book with you? Okay. Please check the table, say page. So you have to check table F of, the table on F distribution, that is page 761. Page 761 and degrees of freedom 3 and 40, right? So 3 and 40. So the value is actually 2.61. Let me check. 2.84, okay? So this value is equal to 2.84, okay? So then what does that mean? This value is equal to 2.84 and F0 is greater than the critical value, right? Okay, F naught is greater than this critical value, so what would you say? You say you're going to reject null hypothesis, right? You're going to reject null hypothesis. This is the what we observe, okay? So we check the table, right? Originally, we only know this number, and this number, right? And basically, this is the information from the samples. Okay, from the sample we know, okay, because of the inference we just made, we know this is the SSF, this is SSE, right? And from all these numbers we know this is M. Hold on, I think there's something wrong here. It should be, yeah, you got it right. It should be, so this is MSE, okay? So we should have, sorry about that, so you got it right. So because F naught, so finally I realized someone understand what I'm talking about and listen quite carefully. That's good. Okay. So it should be MSF divided by MSE, right? And so this is 104, right? 104 divided by 39.9. So can anyone tell me what's the number here? 4.2. Okay. 2.4. 2.61. Okay. So, you know, it's quite encouraging to know someone really understand what I'm talking about. So anyway, I got it wrong here because 39.9 is MSE, right? It is not F naught, okay? So if you want to get F naught, it should be MSF divided by MSE. And so the number here is 104 divided by 39.9. So finally we get this is 2.61. Okay, the observation value F naught is 2.61. And we just found out what is the critical value. The critical value is 2.84. We checked the table, we found out it is 2.84. So this value is actually less than the critical value, right? So what would you say? You say accept H naught. Okay, accept H naught. Any questions? In the next few hours, we're going to get 2 more examples. Okay, let us stop here.